Have you ever looked at a chart of financial data and just felt like it has a memory? Like what happened yesterday is still echoing into today? Well, you're not wrong. But figuring out what that echo really is, separating the actual signal from all the distracting noise, that's a really fascinating puzzle. So, let's get into it. Just take a look at this chart of U.S. 10-year Treasury bond yields. It really feels like there's a pattern here, doesn't it? When the yield starts to drop, it kind of keeps dropping for a little while. It's almost like the data remembers where it was a day ago. But how strong is that memory really? And is it a direct connection, or is it something trickier? All right, so think of us as data detectives. We can see that today's price isn't just some random number, it's definitely connected to its past. Our job is to figure out the real story, to uncover the direct relationships that are hiding in plain sight. But to do that, we're going to need the right tools for the job. Okay, so the first tool in our detective kit is the one we grab to measure what seems obvious right on the surface. It's the most straightforward approach to check for this memory effect, and it's called autocorrelation. The autocorrelation function, or ACF, sounds complicated, but it's actually pretty intuitive. Auto means self, so it's literally self-correlation. It just measures how related a data point is with its own past. Think of it like measuring the strength of an echo. How much does today sound like yesterday or the day before? The ACF gives us a score for each of these time gaps, which we call lags. Now, this is where it gets really interesting. When we use our ACF tool on real data, like Google stock or those treasury bonds, we get these charts. Each bar shows you the strength of the connection to a past day. That first big bar, that's yesterday. The second one, the day before that, you get the idea. And in both cases, wow, the bars start super high and then slowly fade away. It looks like a powerful, persistent memory. Looks like a slam dunk, right? Case closed? Well, not so fast. Here's the twist. That picture we're looking at, it's contaminated. See, today's price is related to yesterday's price, and yesterday's price is related to the price from the day before. The ACF is picking up on all of that at once and mixing it together. So that link we see between today and 2 days ago, it might not be a direct link at all. It could just be an echo of an echo. We're seeing ghosts, and it's making the whole picture blurry. So to clean up this contaminated mess, we need a sharper tool. More than that, we need a sharper way of thinking. And to get there, we're going to take a quick little detour to understand a concept that honestly changes everything. The secret to finding the true direct echo is to learn how to shrink the universe of possibilities. Instead of asking about a connection in a total vacuum, we need to ask about it while taking other information into account. It's all about narrowing our focus to finally get a clear view. And trust me, the easiest way to understand this is with a cookie jar. So imagine we have 20 cookies in this jar, all laid out like you see in this table. Different kinds of chocolate, some with nuts, some without. Okay, first question. If you reach in and grab any cookie at random from all 20, what are the chances it has nuts? Well, there are 12 cookies with nuts, so that's 12 out of 20, which is 60%. Simple enough. But now, let's ask a much more specific question. What's the probability it has nuts, given that you already know it's a dark chocolate cookie? Suddenly, our world of 20 cookies just shrank to only the 9 dark chocolate ones. And in that smaller world, 6 of them have nuts. The probability just jumped to almost 67%. The answer changed because we added a condition. And that, right there, is the magic of conditional probability. It's the chance of something happening given that you already know something else is true. It lets you update what you think based on new information because you're asking the question inside a new, smaller reality. All right, cookie break is over. Now that we've got this new superpower, this powerful idea of given that, we can go back to our financial mystery and build a much better tool. So let me introduce you to our advanced tool, the partial autocorrelation function, or PACF. You can think of it as the ACF's smarter, more precise sibling. It basically uses conditional probability to measure the pure, direct connection between today and a past day, after it surgically removes all the contaminating echoes from the days in between. It cleans the signal. So let's put it this way. The simple ACF asks a blunt question. What's the link between today and 3 days ago? But the PACF asks a much, much smarter question. It asks, what is the direct, leftover link between today and 3 days ago, given that we've already factored in the effects of yesterday and the day before? It's hunting for the pure connection, not the echo of an echo. Okay, this is the moment of truth. We have our simple blurry tool and our advanced conditional tool. So let's put the results side by side and finally see what the data was really trying to tell us all along. And wow, just look at that. It is night and day. On the left, you've got that blurry ACF plot for the Treasury bonds, that messy trail of correlations just slowly dying out. But on the right, you have the PACF plot. It's sharp, it's clear, and it tells a completely different story. So what is this clean plot telling us? Well, that huge spike at the very beginning, at lag 1, that's real. Today's value has a strong and direct connection to yesterday's. But then, look, almost everything else drops to zero. All those slowly declining bars in the ACF, poof, they were just noise, ghosts of that very first echo. But wait, look closely. We also see these two other little spikes, at 8 days and 19 days. That's the true hidden memory that our first tool completely missed. So the bottom line is this. The moment we switched from a simple question to a smarter, more specific, conditional one, the whole picture just snapped into focus. We filtered out all the noise and finally found the true signal. That is the incredible power of this approach. And this isn't just some neat trick for data scientists. This conditional way of thinking is like a superpower for making better decisions in all parts of your life. Why? Because it turns out our gut intuition is often really, really bad at this stuff. Let me give you a classic example. Imagine there's a rare disease out there. It only affects 0.5% of the population. There's a screening test for it. That's pretty good. It only gives a false positive 5% of the time. Now, you go and take the test, and it comes back positive. So what do you think the probability is that you actually have the disease? Go ahead, take a guess. 95%? 90%? The real answer, the conditional probability that you have the disease, given that positive test, is just 8.3%. I know that sounds completely bonkers, right? It feels so wrong. But I promise you, the math is solid. So what on earth is going on? We're falling for something called the base rate fallacy. Our brains latch onto the test's 95% accuracy, and we completely forget about the most crucial piece of information. The disease itself is incredibly rare. Because it's so uncommon, the huge number of healthy people getting a few false positives completely swamps the tiny number of sick people getting a true positive. Without that, given that thinking, our brain confuses the test's accuracy with our actual personal risk. And really, that's what this all comes down to. Are you seeing the whole picture, or are you getting misled by contaminated data and hidden echoes? Learning to ask, given what, can fundamentally change how you see the world. So the question I'll leave you with is this. What hidden echoes, what unquestioned assumptions are influencing your decisions every single day?